Okay, today we continue. We continue with the last section of chapter 3. Our pace is still very fast ahead. Now it's week 4. We should at chapter 2 now. But we already come to the end of chapter 3. So we'll move a bit faster. So today we look at only one thing, which is DM theorem. It's a French word, Moivre. I also don't know how to pronounce that. So it's a I just simplify as a DM theorem. Okay, basically, why it is important to study this chapter, because it's very useful when we have complex number with power and roots. Okay, with power and roots, and it's very useful in solving polynomial equation. Polynomial means y equal to x power n something, right? And to solve trigonometry identities, mean you want to find some direction or some length in a trigonometry setting. So later I'll give you two exercise question in applying this DM theorem. Yeah. Okay. So let's say we have a multiplication of two complex number, which is in polar form, r with the angle theta. You multiply with another polar complex number, r with the theta. You will get r squared and 2 theta. Right? So this is for multiplication of complex number. So if you have more and more multiplication, the top one is double multiplication. What happens if we have many, like maybe 5, 6, or maybe in hundreds of multiplication? So the example, let's say we have 3 multiplication of polar complex number. The same set r with theta, you multiply with 3 times. So you will have r cubed r theta. Right? So you have 4 means r4, 4 theta. So in general, DM theorem state. So if the question asks you to solve using DM theorem, the first step, we expect you to write this equation, the general equation on your answer. You write bracket r angle power n equal to Rn and multiply by the angle multiplied by n. N is how many times you multiply the things. Okay, and this one is in polar form. In polar form. Polar form. Just take note that polar form do not work on addition and subtraction. Just take care of that. If you have 2 polar form complex number and you need to add them or subtract them, you cannot do this way. You need to convert it to Cartesian, then do the Cartesian, then convert back to polar. That is the thing. Okay, the rest you read. Okay, so if we have a problems, polar complex number 3 with the angle of 20 power 4. So by the general equation, we know that the real component 3, we multiply by 4. And the 20 degree will multiply by 4 also. Yeah. So your step should be 3, not multiply, exponential 4, and then 4 multiply 20. Yeah. And so on. So this, you should know how to press the calculator. All right. Any question on here? All right. So this basically, if you understand this one, is actually conclude this section. Yeah. So Just demonstrate one more example. The A, I think you should able to do. I demonstrate B. Demonstrate B. Let's say you have -2 plus J3. This is in a Cartesian. So how do you apply uh, the DM theorem for the Cartesian? So A, you already know. A is a polar form. You should able to do. Right. Okay, I skip A. A is very easy. A is 2 power 5, and then 5 multiply 35. Again, in test, if you see the DM theorem in the question, first step is to write the general equation. This one got marks. Okay. Okay, let's say for B. For B, you need to convert Cartesian into polar form, which is you need to find the modulus and also the angle, which is the argument, ARG, argument, right? So this is when you come to this section, we assume you already know these steps already. We need to find the x squared plus y squared and square root. So you square root the x squared, y squared. Then angle will be the tangent theta, and inverse it. Okay. So you press calculator, you will find square root of 13, and angle is 123.69. This is in quadrant number 2. Quadrant number 2. And all the angle is always from the real axis. Always from the real axis. So careless mistake sometimes will be in the angle. You lost here. You don't know what quadrant it is when you see negative. Right? Okay. So by using the Moivre theorem, you should be able to know. So the Moivre theorem, you write the general equation, this one, R theta power n equal to R power n, and multiply the angle with n. So with this, once you have the polar form, this is what? 13. 13, if you change into exponential, will be 13 power 1 over 2. Right, in the index form. Okay, this one will equal 13 power 2. Okay, so this question asks you power 6. So what you do, you just you write this equation, the amount equation, then you power 6, then angle will be 123.69 power multiply 6. So you have 700 angle something, but 700 something, it just means that it go a few cycle, circular motion. But what is important is it fall at what quadrant, at what degree, right? So you minus 3720 something, 36 t multiply 2. Therefore you cannot. Okay, so you minus, right? So you minus 360, you get 382, which is one cycle and a little bit. So you minus again. Actually, you can straight away minus 2 times 360. Because at the end, we want to know what quadrant it is. And you always calculate from the positive axis. Right? So this one, 700 something means it will go a few rounds. But important is to actually adhere. 22.14. Okay. You stop at there. Okay. So of course, in the test, what should you write? You can write in this form, means 700 something, you can stop here. Right? But in a real application later, you don't need to write this one. You need to simplify it so that your staff know actually what you are saying. Okay, so for example, if this case, so I think something wrong with my number. 13 power 6, 3, correct. Okay, so it means that you need to convert all these numbers. Means that if you talk to technical guy or those bit lower level stuff, you cannot tell them what is this number. You have to tell them, okay, look, the object will be, for example, 2,197 meter ahead of you, and you look at the angle of 22 degrees. Okay. Okay, so this one, I think if you understand this one, the example of B, you should able to do this example, right? So observe the step. The step actually convert Cartesian into polar. Then recall the DM theorem, right? Yeah. So by looking at this, you know that this one is in second quadrant, right? Mm. So this one you go home and look at it. If you have question, you come and ask me. Yeah? Okay. So basically, as there's no complex thing there. Uh, um, Something wrong on my slides. I should write in this form and not this. It should be in this in same as the DMO theorem. So this is a wrong presentation. So you should write same format as the DM theorem. Okay. Yeah. So before you come to this 74, square root of 74, there's a step before this, which is you need to write square root of -7 square plus 5 square. And angle of 10 minus 1, 15, sorry, 5 divided by -7. Okay, so this step is actually wrong. The second step here is wrong. Okay. So in polar form, again, just to recall, normally we write in degree, but in some cases, especially you work with the map that related to flying map or ship map that is on Earth, we deal with degree. All right, so 1 degree, one degree equal to 60 minutes. All right. You understand why is the what is degree and minute, right? So let's say this is on a map. You know that your Earth, our Earth got all this line, right? Our Earth is all this, and then you open up the Earth map. You're actually seeing all this line on the map. So let's say this line is 0 degree. You want to fly east 1 degree. It will take you 1 minute to fly 0 to 1 degree. So it's about 60 seconds. Yeah. Okay. Okay. Okay, so sometimes the question will give you one equation and then ask you to express in polar and rectangular. You should be able to convert from polar into rectangular. Yeah. Okay, so rectangular form means you need to write in this form, r theta sine theta. Okay, all right. So with and then this is your homework lah. This is your homework. So we assume you will do your homework in next hour lah. We assume you do. Okay, so with this, one more. I still have root at complex number. Sorry. Okay, so if we square root the polar number, if we square root it, so the general equation is what you see on the screen. So you take a polar complex number, you square root it. So you will get r square root. You change the head, square root head into exponential half. By using the DM theorem, you know that you always multiply the angle with the exponential value, and also the real component you exponential it. Yeah. So you know that square root always have two answer, two roots or two solution. One is negative, one is positive. Okay. Okay. So the understanding actually the same as what we did 10 minutes ago. All right. Yeah, about 10 minutes ago. So let's see. The question asks you to determine two square root of this complex number in polar and Cartesian form, and so the roots, the answer in Argand diagram. Okay. So first is you convert this one into polar form, right? So this will be in first quadrant, right? Okay. So you write, the first step is to convert the question, the formula into polar form, which is square root of x squared plus y squared. Then inverse tangent of your y divided by x. So from there, you get an angle. Then you determine the square root of the solution, right? Is it correct? Is it correct? Is it 13? 25 plus 144. 9, 6. Correct. Yeah. Okay, so this one you read lah. You read a bit. Yeah. It means that this one, if you have two roots there, the roots actually in a different angle, in a different imaginary dimension. The real part still there, but you have another answer roots in imaginary dimension. Okay, so you have angle of 67.38. Another answer will be you need to plus 360. Another dimension, which is 427.78. Okay. Okay, so it's like this. So okay, wait. I show you the. Yeah. We follow the slides. We follow the slide first. Okay, we know that if we have need to find the two square roots, our complex number have two angles. One is 67 degree and 427 degree. Then we square root it. Yeah, we square root it. So this is just means that you are trying to square root the thing, right? So this will be the steps. This will be the steps. So square root of 13, angle half of 67, and square root of 13, half of 427 degree, right? So at the end, you get two answer. Try to observe what is the trend between 33 and 1213. What is the difference between the two numbers? A collinear, and what is the difference in angle? 180, yeah. So it actually is another side. So when you draw, okay, okay, so when you draw, you have two angles there. Okay. So this answer and this answer actually is the same. It's the same. Okay. So 213 actually is minus 146. It's the same. It's the same. It's the same. It's the same. One is like this. One is like this. This one is actually you plus 360. This one plus 360. If you see the question asks you to find 2 square root, if you see question mentioned, determine 2 square root. Yes. 360. Okay, once you have that, you convert back to Cartesian form. All right. So this one back to Cartesian means you change this one to cos and sine. Right. So at the first set, you already get 3 plus j2. You do the same for 213 degree. Also same. Yeah. So you got negative value. It will be in this quadrant 3. Because your first set is quadrant 1. If you see the question asks you to find 2 square roots of complex number, actually another answer is opposite of the quadrant. It's a reflection or reflective answer. Right? Yes. So actually, if you compare the two answers, you can simplify the answer as plus minus bracket 3 plus a2. Means got two roots there. Yeah. Yeah. And to draw in Cartesian, so one Cartesian root is this one, polar form is this one, right? Which one? How to get 13? Actually, it's a 3. 这个 you cos 213 multiply 13. Wait. No, you already find the square root. Do I carry the wrong head? Yeah, square root. Correct. So my PowerPoint slide actually it should be square root 13. So there's a typo error lah. It should be like this. Yeah. Okay. Yeah. So there are typo error. So it should be square root 13. Yeah. Okay, so if you draw on Argand diagram, the first set of root will be on the first quadrant with 3.61 magnitude or modulus with the angle of 33.69. Another one will be from the real axis 213.69 which is 180 degree from the first set. Okay, so this will be the second, that will be the answer if the question asks you to draw on the Argand diagram for the final answer roots. Yeah. All right. Okay. So when finding number of roots of complex number, there will be n solution. What does it mean? For example, this one. If you need to find 2 square roots, mean you have 2 answers. If you need to find a cube root, you have 3 answers. And fourth root, you got 4 answers, and so on. Yeah. So, but for this module, I won't ask you more than 5 in final exam. Right? The most is 3 answers. The most. Okay. But for your test, I only ask you two roots. Okay. So the rest you read. The rest you read. Yes. No, it will turn. It will turn. Turn. Okay. So let's see this one. Let's see this one. So let's say we have a Cartesian complex number and we square root it. So we use the DM theorem. So there's a step to convert this one to here. So 3 plus j3 means you take square root of x plus x squared plus y squared square root. You get square root 34. Right? Yeah. Then the angle will be tangent inverse of y divided by x. You get 30.96. Right? This step I already skipped the calculation. So if this one in test or final exam, you need to show me the x squared, y squared, and tangent y divided by x. So you apply the Diamo theorem. So it means you squared it. You square the r and also divide by half the angle. Okay. So at the end, you'll get this final answer. You convert 5 plus j3 square root, you get 2.4, 15 degree, and or 2.4, yeah, this one is minute, in minute. And you know that another answer for this one will be 180 degree from this one. Okay, so you don't need to go through the calculation. Straight away, you say the second answer is this angle plus 180. Like this. Straight away, you take the first answer, bracket plus 180 for second answer. If you see square root, if you see square root, yeah, I'll show you 1 cube root. Then you convert into rectangular. This is a polar form. 2.4 with the angle is polar form. Convert rectangular means you need to convert into sine cos theta. Right? Then you do the steps. Okay. Why so? You don't understand why 15. If you draw Cartesian, this is your y, this is your x. You got degree. You change this one into tangent, right? This is 5. This is 3. What is the angle? So tangent, tangent theta equal to 3 over 5. So theta equal to tangent 3 over 5. So 3 over 5 tangent is 15.48. is this one. Yeah. Then if it is us to find roots means 180. So from here to here. Mm. Then you do the calculation for cos and sine to get in a more simpler form. It is plus minus 2.3 and j is 0.64. Okay, another one with this I think final exam standard, where just now you only see the simple 1/2. What happens if the question asks you power negative 2.5 25 2 divided by 5? So it was same as using the Diamond also, DM theorem. You see, observe, try to observe the strategy we use. You convert the Cartesian complex number into polar. So this step you should already know how to get square root 205. You should already know how to find 167. Okay, this one is in second quadrant. Okay. Then you use the DM theorem. DM theorem means you take this square root 205 power minus 25 and the angle you multiply minus. This is Diamond theorem, right? Correct, so you press calculator, you will get 0.3449. And if you multiply the angle, you will get minus 67.164. It means it's at this, it will stop at quadrant 4. Because you will stop at this one. So you will stop at here. This one, minus 67.164. You can give me the 200 something lah. You can give me this side, but if it's in mathematics, we always give the smallest number we have, so that more easier lah, right? Yeah. So this is how we do it. All right. So we get the first set answer. So because we have a fifth root, 1/5 is fifth root. Fifth root. So you have 5 root in this complex number. So you see how we do. So because x over 5 there, right? X over 5 you can write in this form. Right? Minus means 1 over something. Minus means 1 over something. So if you have minus in 1 over x power 2 over 5. And you can convert this one into fifth root of x squared. Okay. So if we have fifth root, what does it mean? Means they are symmetrically displaced from one another. You take 360 divided by 5. So they actually have an angle difference of 72 degrees. Meaning 360 you divide by 5. Right, I'll show you the Argand diagram. But means if you have fourth root means 90 degrees each other. You divide by 4, 360 divided by 4. If it's cube root means 360 divided by 3. We have three segments. 120, 120, 120. Yeah? Yeah, can I? All right. So you have this angle. So you know that the first set you find the angle will be minus 16 degree. The second one is you plus 70, right? So if you draw diagram, Argand diagram, this is minus 67 degree. This is the first set. Second set, you plus 72, you get here. Then you plus another 72, you get here. Then you plus another 72, you get somewhere here, and so on. So you get like 5 answer that is. Yeah. So this represents z squared 1/5. This diagram. Yeah, this diagram represents z 1/5 power. If you have z 1, means you only have 1. If you have z power 2, means you have 2 answer. Something like this with the angle. You have z, sorry, square root, not 2. Square root 2, 1/3. Then you have 3. You have 120 degree each. Something like this. Okay, 120 degree means you take 360 divided by 3. Fourth means 90 degree, and so on. Okay, z fourth root, you have 90 degree each other. Fifth is the one like you see on this question. All right. Yeah, so this one okay? All right. Who don't know how to draw Argand diagram for this one? Who don't know how to draw this one? Yeah. Do I need to show you? So you already have the modulus, ma. The modulus is 0.34. So the first one is 0.34, this length, right? But you have the x and y axis, right? You have x and y. So you need to find back lah. What is your x and y? 14 and 3. 14 and 3. So this angle, this is 3, this is 14. And this is minus. The second one is 4 degree. It's about here. And you plus another 72, which is 76 degree. So your Argand diagram, you should show me the angle from here to here. You should show me from the real axis. 72 point something lah. Then the third one is 148. You should show me like this. 148. And then 220. And so on. Okay, 220. Okay. Okay, with this, I think we come to the last slides. So go home and practice on how to find the roots. The answer is at the back of the PowerPoint slides. Okay, so with this, we conclude chapter 3. Yeah, chapter 3. Title answer.